Hello, my name is Hans Wouters. I'm working for the company called Brightwork in the Netherlands and would like to present the results of a study which we did in the Netherlands. The title of my presentation is How to Boost the Biology in a Municipal Wastewater Treatment Works, a case study. We executed a bioremediation program at a particular Dutch wastewater treatment works, which is operated by the water utility of Brabantse Delta. The name of the wastewater treatment works is Halsteren, which is in the south of the Netherlands, a plant with a capacity of around 12,000 people equivalents. At this plant, we tried to do something new. We dosed Aqua Assist microporous granular particles directly into the activated sludge reactor to boost the biology and to aim for a reduction of the production of waste activated sludge. That was the primary goal of the trials. In this presentation, I would like to share with you the backgrounds of the technology and the claims, and last but not least, I will also present the results of the trials. The content of this presentation is, first of all, I would like to indicate why we executed the trials, what the mechanism precisely is. I will explain what it is all about. Then I'll focus on the results, and finally I will conclude the trial results. Why did we try this in the first place? The idea behind the dosing of the material was compelling. The water utility would like to reduce the waste activated sludge, and this seemed to be the right way to do that in a very easy way. The pilot was easy to execute, and finally we decided, let's go for it, and we'll see whether the proof is in the pudding. The claims were compelling, as I said. 20 to 40% reduction in waste activated sludge, a better performance of the biology, an improved settling characteristic in the post-settling tanks, and lower sludge volume indexes, no bulking sludge. That seemed all to be good to be true. But that's the reason why we said, let's go for it, let's do a trial, and we'll see for ourselves what the results were. What is the mechanism behind dosing Aqua Assist? The Aqua Assist solution consists of an engineered microporous silica oxide based granular matrix with particle sizes in the range of 200 to 600 microns, inoculated with a specific proprietary microbial population. The microbes which are loaded onto the inorganic silica are characterized by their high capability for efficient metabolizing, not being filamentous in nature, but flock forming, and enhancing hydrolysis with both lipophilic and halophilic functionality. With regard to their oxic preferences, these microbes are both facultative and aerobic. The granular material is dosed directly into the activated sludge reactor. Within the reactor, the media will typically have a residence time equal to the sludge retention time. The granules are protecting the microbes from predators, bacteriophages and/or toxins, and they will act as a nursery for the biomass to grow under more or less optimal circumstances, with doubling times in the range of 2 to 3 hours once the material is dosed into the activated sludge basin. The ideal growth of the microbes in the granular environment will have a relevant impact on the total biomass present in the activated sludge tank. This impact has been calculated for the Halsteren plant with a total activated sludge volume of 2,600 cubic meters, an average MLSS content of 9,000 kilograms, and a sludge residence time of 19 days. 1 kilogram of product contains around 50 grams of microbes, which is only 5% by mass, but with a maximal growth potential in a secured environment. During the test period with Aqua Assist, that was from April until around November 2019, we dosed daily about 600 grams of product, which equalized the addition of only 30 grams of microbes per day. Although this dosage seems low, the high sorption capacity of the porous media and the protective properties that it provides enable the microbes to enter rapidly into an exponential growth phase. Typical doubling times of around 2 to 3 hours, a yield was established of 50 to 100 kilograms of biomass within a 24-hour time frame. This means that the Aqua Assist originating biomass roughly contributes to at least 10% of the total biomass present. Studies have revealed that the Aqua Assist dosing initiates a shift in bacteria species, which favor the process conditions for wastewater treatment. This is illustrated in the table where you can see the species present before starting the dosing of Aqua Assist and after 1 year of dosing of the material in an activated sludge environment. How did we test it? We simply dosed twice a week 2.1 kilograms into the return activated sludge. The operators attended site only twice a week, and that was primarily the reason why we did it only twice a week. So during this period, consistently twice a week, the 2.1 kilograms of material has been dosed. And during this period, we observed the changes in the water quality, if any. We tried to establish the mass balances for sludge, and we carefully determined the amount of excess sludge which was carried away from site. In this sheet, you can see the dosing point, where the operator simply manually dosed the right amount into the return activated sludge flow. As I said, he did that twice a week, as it was only attended twice a week. The granular material was stored in buckets in a dry environment. There were no difficulties reported for dosing the material. It was an easy job. And then I would like to focus a bit on the results. We've compared sets of data from 2017 and 2019. The operating conditions for these 2 years were found to be more or less the same, and hence, in comparison of the results, with and without Aqua Assist could be made. As you can see, the sludge volume index levels remain fairly constant, while we increased the MLSS from 2.7 to 3.7 grams per liter in 2019. The average sludge discharge in kilograms per day reduced with approximately 30%, while the yield, based on feed BOD, reduced from 0.76 down to 0.55 kilogram of biomass per kilogram of BOD in the feed. The overall results were very promising. As you can see, the 30% achievement in reduction of waste activated sludge was more than the water utility took for granted on beforehand. Summarizing, we may conclude that the tests were very successful. The water utility was very eager to continue with the trials, so that's the reason why in 2020 the trials are continuing, and we have extended the trials to another site of the same water utility. I would like to thank you for your attention. If there are any further questions, please drop me an email and I'll try to answer. Thank you very much.